Cool, you're doing these.
Thanks. Yeah. Okay. We're here with Michael Laine today. How you doing?
I'm good. I'm good. I was just looking at your channel and some of the people that you've interviewed. It looks really great. It's a good project you're working on.
Thanks. Yeah. So I understand you're working on lunar space elevator concept. Could you tell us a little about that and how this is going to work?
Sure, sure. A lot of people are familiar with the Earth elevator, so I'll use that first. Imagine you have a ball and a string, and you're spinning it over your head. The string in the middle stays straight, right? So now expand that to an Earth-sized system. The Earth is rotating. You have a counterweight, a satellite, extraordinarily out in space. With a long, strong string back to the Earth, the mechanics are still the same, and you can basically build an elevator, a ladder, to climb back and forth. So I was part of the original NASA Institute for Advanced Concepts research team to take a look at that back in 2001. And over time, we realized a couple things. One, that is a project that's probably about ready to come out of science fiction, but we still can't build it yet. We don't have the materials for it. And we knew that. We knew that when that final paper got turned in. However, over the years, my team kept working on different aspects of it and different parts of it. And in about 4 years ago, we came across the idea of, instead of trying to build a system on the Earth, which we can't do yet, we focus instead on the moon, which we can. Now, the mechanics of that are a little bit different. You've got the Earth on one side, the moon on the other. You go to this point here, not the middle, but the equilibrium point between the moon's gravity and the Earth's gravity. This point's called the Lagrange point. So that balances the gravity between those 2 points. And what we'll do is we'll take a rocket from Earth to the Lagrange point, drop a string down to the surface of the moon, pull that through the Lagrange point towards, not touching, but towards the Earth. The Earth has enough gravity to hold that string straight because it's pulling on the counterweights. Yeah, okay. So once we've done that, then you can just take rockets from Earth to the Lagrange point and then a robot down that last bit down to the surface of the moon. And the reason that that's important is that there are 13 nations with about 30 rockets in current inventory that are able to achieve this feat. So what you'd have, instead of an us versus them Cold War effort to go to the moon, the Americans versus the Soviets, I think you'd have a global cooperation where many nations participate in exploring and developing both the Lagrange point and the surface of the moon. So that's really what we're trying to do.
I see. Yeah. So what kind of technical challenge do you foresee for this kind of effort?
There's a lot. We break the challenges really into kind of 4 main areas. There's definitely technical, but there's also finance and business, political and culture, and even legal and military problems. So we really break them down into technical, business, outreach, and framework. And so within the technical, which is what you asked, there's a lot of problems. It's important to know that the string, the material needed to make this elevator does exist. There's about 7, maybe as many as 12 candidate materials that are strong enough to make the string. Now, none of them are perfect. We call that Goldilocks engineering, when something is just right. Nothing is just right, um, but the string that we need is strong enough. But some of them have they fail under intense ultraviolet. Others fail under radiation. So they break down for a lot of different reasons. So none of them are perfect, but they're all pretty good and they're all strong enough. And that's really the hardest part. Then, of course, how do you land that first string down to the surface of the moon? That's really, really challenging. There's a lot that can go wrong with that. When we drop that string down to the surface of the moon, we're going to be surveying the area, scanning it. When you drop the string down, the counterweight acts as a pendulum, so it'll kind of move over the surface of the moon. We have to release it just right so that it can sink into the moon and stay there. So that's pretty challenging. The first stages are all exclusively robotic. So if anything goes wrong, there's not anybody there to fix it. And we did that on purpose, just focusing on robots in the beginning, but that leaves a lot of liability. There's a lot of problems that can happen with that. So there's a lot of technical problems. We don't claim to have all the answers yet.
Awesome. Yeah, you mentioned there might be some business and challenges. And what do you think of legalities of this effort?
Well, I think that's still an unstudied question. There are 3 or 4 major universities in the world that teach and focus on space law. There's a group in the Netherlands, there's another one in Canada, and then there's another one here in the United States in Washington, D.C., George Washington University. Each of these schools have their own philosophy on what's going to happen up there. There are 6 major treaties dealing with space. The United States has signed most of those, but the one treaty that specifically focuses on the moon, the United States did not sign. So that's a big ambiguous question that I think is probably going to be. It may be a pretty serious problem down the road. I don't know yet. In theory, we should be able to have rights to do mining and development on the moon. Most of the space law treaties are based off of law of the sea. Now, the law of the sea is hundreds of years old. It's well codified. People know what to do when they deal with the sea. And the sea is a good analogy because there's this common heritage of humankind. And the moon is treated that same way. But in the same way, you can have fishing, you can do recreational scuba, you can do oil, you can build oil rigs, you can create fish farms, enclosed areas. And so you do that under the auspices of economic development. And when you stake a claim to a particular area, you get your claim, but then you get an economic exclusion area around that claim. And we've been doing that for hundreds of years, and that's kind of a well-proven strategy with the ocean. And we feel like that will also apply to the moon. Not everybody agrees with us on that.
I see. Are there any other projects you're working on now?
Well, the things that we're working on now are really lots of little pieces towards the bigger idea. We're developing some academic programs, some financial programs. We're starting to spin off a little bit of our commercial development. We've learned a lot of things over the last almost 15 years. And so we're in the process of commercializing some of those spinoffs. And we think that that's pretty darn important, because a project like this, you have to figure out how to pay for it. And that's not always easy. You can't just always ask Uncle Sam or various other governments for money. You have to be able to show that you can do something with what you've learned. And so we're really focusing on doing something with the knowledge that we've gained.
Awesome. Well, that's all the questions I got. Anything you would like to add?
No, just it's a developing program, and over time, as more people get involved with it, we think that there's a real future for this project. That if we're right, we transform human civilization. If we're wrong, we still learn a lot along the way. So we think that that's pretty valuable. Oh yeah, actually, Heidi, I do have something to mention. We think that, I know most of your fans and viewers are focused on Mars. I'd like to talk about how this relates to Mars. The Earth elevator has been in science fiction for 40 years. It was an idea that was first conceived over 100 years ago. So it's going to take a while before we actually get the Earth elevator built. But I think that we'll actually build the lunar elevator first, probably a Martian elevator next, and then finally come back and build Earth's elevator. So I think that that's probably important. And then the other thing is that we talked about the Lagrange point, right? This point here, that equilibrium point between the Earth and the Moon, you're effectively at zero gravity, null gravity. The Earth's gravity on one end has been nullified by the Moon's gravity, which means once you get to that point, getting to Mars, getting to the asteroids, getting to other places in the solar system, it's pretty easy. It's pretty easy. So we feel like that's probably the best jumping off point for any future development, especially from Mars. So I know that some of the folks that watch your shows probably have a more specific, direct plan to go to Mars. But I really do think that long term, the Moon is going to play a pretty critical role in getting to Mars.
You're right. I think a friend of mine did mention that it's possible to use an elevator like this to sling stuff to Mars.
Yeah, exactly. We'd really like to do that down the road. The sling stuff would be coming from the Earth elevator. You can't really sling things very well from the lunar system, but by launching from the Lagrange point, you lower your total cost of energy, which means you can bring more cargo and heavier cargo to Mars by starting at the Lagrange point. So that's what we think. We can imagine a solar system where 13 nations use current rocketry to launch to the Lagrange point. That becomes an assembly station, and then together they go out to Mars. That's how we kind of envision all this happening. So we'll see. It's going to be a little while, but that's what we're working towards.
Awesome. Thanks, Michael.
Sure. Thanks for having me. I appreciate it. Have a good day.
You too.